So this is 2019 number 4. So please have the words out to match the diagrams we're going to talk about. So we have a cylinder. This is my rough sketch. And the diameter of the cylinder is 2 feet. And we have some water in the cylinder. And they're saying that that is referred to as H. And they also give us the function that dH dt is equal to negative 1 over 10 times the square root of h, which I like to write that as negative 1 over 10 h to the 1/2. All right, so question A says find the rate of change of the volume. So we're looking for dV dt, the rate of change of the volume of the water in the barrel with respect to time, and the height of the water is 4. Well, the volume of a cylinder is pi r squared h. Now, notice I have 3 variables here. Now, when you take the derivative, you do not want these 3 variables. You only want to get it down to 2 variables. So we have to replace one of them. Well, obviously, we're keeping the v because we have looking for dv dt, and we're keeping the h because we're looking for, or we have h equal 4. So the variable I want to get rid of is the r. Now, if r is changing or moving or in its value in any way, we have to replace it with some function that involves h. So we would need r to be something in terms of h. But, so for example, if it was a cone, then the radius would be changing every different height of the cone. But because we're dealing with a cylinder, the radius going all the way through is always going to be 1. So I can then write this as v equals pi times 1 squared h, because the radius is not changing or altering any height along that cylinder. So now taking the derivative with respect to time, I have dv dt equals, I have pi, which is a constant, and then the derivative dH dt. dH dt we know, so we have dV dt equals pi times negative 1 over 10, and we can replace the h with the 4, so we have 4 to the 1/2. So my answer is going to be negative 1/5 pi, and then I want to label it, and because it's volume, it's cubic feet, because the rate, it's cubic feet per second. On to part B. Part B says when the height of the water is 3 feet, is the rate of change of the height of the water, so we want the rate of change of the height of the water, so that again is going to be dH dt, the rate of change of the height of the water with respect to time, increasing or decreasing. So to determine if dH dt is increasing or decreasing, so now this is the function. We want to determine if that's increasing or decreasing. So we need its derivative. So we need the derivative. So we have d squared h dt squared. That's the way to write the derivative, or in this case, which is the second derivative. So if I was going to take the derivative, again, I'm going to start with dH dt, which is negative 1 over 10 h to the 1/2. So I'm going to have 1/2 times negative 1 over 10 h to the negative 1/2. And so I have, and then I need the dH dt with respect to time. So I have the second derivative, and I want to evaluate that at 3, h equals 3. So I have negative 1 over 20, and then I'm going to have h to the 1/2 in the denominator, And then dH dt, this piece I'm going to replace with that. So I'm going to have a negative 1 in the numerator and a 10 in the denominator and an h to the 1/2 numerator. So I'm to get cancel 1 over 200. And that is greater than 0. And so that means that the rate of change of the height of the water when, again, h equals 3 feet, with respect to time, is increasing because the derivative, which in this case is d squared h dt squared, is greater than 0. So moving on to part 4, question 4c. It says, at time t equals 0 seconds, the height of the water is 5 feet deep. Use separation of variables to find an expression for h in terms of t. All right, so we're given that the rate of change of the height with respect to time is negative 1 over 10 square root of h. All right, so separation of variable means that we need to get all the h's on one side and the dh have to be in the numerator, and all the d's and t's on the other side, and the t has to be in the numerator. So I am going to multiply both sides. So I'm going to have negative 10h to the 1/2 dh. I'm going to take that back, excuse me. I'm going to have negative 10 dh over h to the 1/2 in the denominator equals dt. And now I'm going to integrate both sides. So I'm going to have negative 10h to the negative 1/2 dh equals t plus c, my constant of integration when I integrate the t. I could have left the 1/10 and brought that to the other side. Okay, so integrating, I get negative 10h to the 1/2 over 1/2 equals t plus c. So I get negative 20 square root of h equals t plus c. And I'm going to solve for c. So I'm going to use the fact that h equals 5. So I have negative 20 square root of 5 equals t, which is 0. The height is 0. So I'm going to have 0 plus c. So c equals negative 20 square root of 5. So going back here, I have negative 20 square root of h equals t minus 20 square root of 5. Now it specifically says for h in terms of t. So I'm going to solve for h. So I have h to the 1/2 equals negative 1 over 20t plus the square root of 5. And now I'm going to square both sides. So I have h at t equals negative 1 over 20t plus the square root of 5 quantity squared. So that is the separation of variable to find an expression of h in terms of t. So there is my expression.